So this question, students who work at a local coffee shop recorded the drink orders of all the customers on a Saturday. Okay. They found that 64% of the customers ordered some sort of hot drink. And 80% of those, so that 80% is not overall. That 80% comes from just the people who ordered hot drinks. 80% of those customers also put cream in their drink as well. So they wanted to find the probability that a randomly selected Saturday customer orders a hot drink and coffee cream to the and adds adds cream to the drink. Okay. So this isn't a given, that problem. There's no given. There's no given. It's just one and the other. Okay. So I created a tree diagram for this. Just because I saw that one event was ordering a hot drink and then the other event was putting cream in it or not. So I did this and I put the probabilities in there. The problem is they don't give me all of the probabilities. So these guys down here, I don't know anything about the people who don't order a hot drink. I don't know anything about them. But luckily, I don't need to know anything about them because the question just wants this path. The question only wants hot drink with cream in it. That's all it wants. Doesn't need anything else. If the question said, what's the probability that a person puts cream in their drink? I couldn't do that problem because I would need this guy down here. I would need these, but I don't need this for that problem. So it's not really a big deal. Okay. So you're just multiplying 0.64 times 0.80 and you get 0.512. Thank you. Okay. So what's the probability they do both? That is an overall probability. That's everyone. So this guy right here is not this is not a conditional probability. There was no condition, right? A condition is given. If there was something given, there was nothing given. It's doing both. Okay, it's doing both. All right. Okay, so one more problem, and then I think that's the last problem of the notes. Yes. Okay, so I want you to do the last example, number 8. Example number 8. Example number 8. I want you to do this one. I'll give you some time to do it, and then we'll talk about it. Okay, so after surveying 995 adults, 81.5 of whom were over 30. Okay. The National Sleep Foundation reported that 38.8% of all adults snore, and 32% of the respondents were snorers over the age of 30. So they give us 3 pieces of information, but the pieces of information are different than what we're used to getting. Okay. So the first event I saw was over 30, under 30. Right? They gave me a percent. They said 81.5 of the people that they surveyed, the 995, okay, were snorers, or sorry, were over 30. So I'm going to change that to a decimal. That means the rest of them had to be under 30. So that would be 0.185. Okay. And then the next one I highlighted. The reason I highlighted it is because it's different than what we've seen before. So then the National Sleep Foundation found that 38% of all adults snored. So that is not a condition. That is not a conditional percentage. That is of all snorers, right? So what that means is this way and this way together makes that. Okay? It would go over here. So if I found that and I found this, I added them together, it would be that percentage there. Okay? 32% of the respondents were snorers, and 32 of the respondents were snorers over the age of 30. That's a path. That is a path on here. 32% were snorers over the age of 30. Over the age of 30 and snorers. Okay, 32% doesn't go on my tree diagram. It's the result of both of these guys being multiplied together. Okay, it's not, it's both snores and over the age of 30. So that goes there. So that means I have to figure out what this guy is here. Well, how do I figure this guy out? There you go. Use division. Instead of multiplication, you use division because this number times this number should equal this number. So you consider this an x. So you divide both sides by 0.185 and you get 0.39393. And then you can check it too. You can check it 0.185 times 0.393 should equal this guy here. And it does. Okay. All right. So I got that. So now I can figure out this guy here because either if you're over 30, you're either a snorer or you're not a snorer. You can't be both. You either do snore or you don't snore. So these two together have to equal one whole. Okay. So I subtract from one whole and I get 607. Okay. Because this plus this has to be one whole. Because there's only two options. You either have to snore or you don't snore. Okay, so this guy times this guy has to equal this. So I just divided. I divided. I use this as my x and said divided both sides by 0.815. Okay. But the question asks, what percent of respondents were under 30 and did not snore? That's one path I don't have. I don't have under 30 and not snore. That's the path that I need. If I had this number here, that would be my answer. Okay? That's what I'm looking for here. That's what that path says. It's under 30 and not snore. Okay? So I got to fill in some blanks here. Well, let me fill in this blank first. 0.815 times 0.607, we get 0.495. 495. Okay. I can't do the rest because I don't have this data here. But I do have a piece of information I haven't used yet. That one there. That says people who snored. Right? Well, there's two paths to people who snore. This path here, which I already have, and this path here, which I don't have. So that means this guy and this guy are going to equal this guy. So I have to do some subtraction. And then when I subtract, I get 6.6%, which is 0.066. Okay. Now that I have that, I can figure out what this is going to be. Because this guy, 0.185 times this guy, has to equal that guy. Use division again. Okay. So 0.066 divided by 0.185, I get 0.357. Yeah. Yeah. Did I subtract wrong? 6.8. Sorry. There we go. 6.8. That's going to change this guy a little bit. Let's see. 0.36. Say it again. 368. All right. Thank you. A little bit off, but still, it's important. Okay. So if I'm under 30, you guys are under 30. You're either a snorer or you're not. Either you do snore or you don't snore, right? There's no in between, right? Even if you're like, I kind of snore. No, that's a snorer. Or you don't at all, right? So there's only two options here. So that means this guy plus this guy should be one whole. So I subtract from one whole, 1 minus 0.368, and I get 0.632. And then I multiply for the last path, the one that I highlighted in purple, and I get 0.117. Uh-huh. If you use a formula, yes. If you use a formula, yes, you have to show. If you don't, you don't have to. So it just depends on what you use. Okay. No. Like I said, if you use a formula, you don't have to. They're just looking for your method. Like if you use like this question, I'm not going to use a formula because I can do it from the tree diagram. The next one though, I'm going to use a formula. I can't do it from the tree diagram. I can use it, but it's not going to give me my answer. So here we go. So what's the percent of respondents who were under 30 and did not snore? 0.117. So I want to label that as my answer. I don't want to just put a bunch, because there's a bunch of numbers on here. There are a lot of numbers on here, so I want to not circle it, I want to label it. So the probability under 30 and no snore equals 0.117. That labels it exactly what it was. Because you don't want your reader to have to search for your answer. You want them to find the answer. Even if you were to box this guy in, what is it? You know, you can't assume that people know what this means. So label as best you can. Okay. Okay, so the last question, are they independent? Are snoring and age independent? Are snoring and age independent? So for our independence, we're going to use this guy, the formula we've used before to say, is it or isn't it? Is it not independent? This guy right here. So you have age and snoring. One can be A, one can be B. It doesn't matter which one you use for A. It doesn't matter which one you use for B, as long as you're consistent. Okay, so if you choose snoring for A, it's A on both sides. If you choose age for A, it's A on both sides. Okay. Okay, so let's look at it. All right, so since on my tree diagram I have age first, I'm going to use age as A. So probability of age given snoring, I want to make sure that's equal to the probability of age. That's what I want to double check. Age, I have two ages, over 30, under 30. Which one do I use? It doesn't matter. It does not matter which one you use. Same thing, snoring. I have snorers and I have non-snorers. Which one do I use? It doesn't matter. It does not matter. Just make sure you're consistent. So for age, if I use over 30, I'm also going to have to use it over on the other side of the equal sign. Okay? So I will say probability of over 30 and a snorer. Okay. Well, the easy one is the probability of being over 30. What's the probability of being over 30? 81.5. They told me that, and it's on my tree diagram. 81.5. That's the probability of being over 30. Okay, so I'm going to put that one there, 0.815. The other guy is a conditional probability. I'm going to have to use the general multiplication rule. This guy here, it's a given, right? So I have to use this formula. Okay, so the probability of both over the probability of B. Okay, so I got to find out the probability of over 30 and snoring over the probability of snoring. That's what number is going to go there once I plug it in and divide. Okay. So over 30 and snoring, that's a pass. Over 30 and snoring is right here, 0.32. So that goes on top. Bottom is just snoring. How many paths are there that lead to snoring? 2. So I got to add them up. So one of them is 0.32. The other one is 0.068 because these two paths lead to snoring. So I add those up and I get that point, and I get 38.8. That 38.8 number. Okay, go to my calculator. I get 0.827. Okay. Very close. Very close. But they're not the same. They wouldn't even round to be the same. Like if I rounded if I rounded each of them, this guy would round to 0.83. This guy would round to 0.82. They're very close. Okay. So I would say not equals. And I would say snoring and H are not independent. They're dependent, or you can say they are dependent. Either way, it's okay. How close is close enough? Because that's the question I always get. How close is close enough? This is what I say. If you can round them and they're be about the same, then they're okay. So let's say, just say for argument's sake that this was this. I would probably say they're the same because they would round to be the same, right? I would say those are pretty close. Here's the thing. If you consider them, if they're close and you consider them to be the same, and then in your explanation you say they are independent, I'd give you full credit, right? So for example, let's show you this. I'm just going to give you a generic example. Let's say you do your math and you come up with this 0.714 and 0.711. If you think those are the same, then you would say blah, 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 whatever the two A and B are independent because the probabilities are equal. Or let's say, no, they're not close enough. Nope, they're not close enough. Nope. Then I would expect you to say A and B are not independent because the probabilities are not equal. Just be consistent. So if you say they're the same, you got to say independent. If you say they're not the same, not independent. Okay? because how close is close enough? I don't. It's a judgment call. It's a judgment call. But what I wouldn't do is they're not the same, so they're independent. That's not true, because if they're the same, they're independent. Okay. So in terms of how close is close enough, I give a lot of leeway. I'm more interested in how you got to your conclusion. How did you get to your conclusion? That's what I'm more interested about. Okay. Little things like, are they the same? They're kind of subjective, because there are no two numbers that are the same. So it's really subjective. But yeah, as long as you're consistent and as long as your work backs up that claim, then I'm okay with it. Okay, I'm okay with it. Okay. All right. Okay, so I want you to try to do some practice on your own. So I have the assignment. It's from your book. I want you to start on that. We're done with the notes. This chapter